Okay, so let's see this question. It's a very conventional type of question, block over block problem in friction. So the question is, we have two blocks here, 10 kilogram and 2 kilogram, and we are applying a force F on the 10 kilogram, whose values are differing like 40 Newton, 60 Newton and 80 Newton. So in all three cases, we have to find out the acceleration and friction between these two blocks. What are the acceleration of these blocks and what is friction between block? Whether they are moving together or with different acceleration, whether the friction is static in nature or kinetic in nature. So with this one problem, we are going to see detailed analysis of this type of problems. Okay. So this lower surface is smooth. There is a friction of coefficient mu equals to 0.5. So first of all, we will calculate the maximum available friction. So maximum friction is given by mu into normal. So if you talk about normal upward, downward must be how much? 20. Okay. So normal how much? 20. So friction is mu into normal. So mu 0.5. Normal how much available? We have 20. So it would become 10 Newton. So we have the 10 Newton of maximum available friction. Okay. Now we will see that if they are moving together, or suppose like we are trying to see the 40 Newton case. So for 40 Newton case, when apply on this one side 40 Newton, so 10 kilogram backward friction, how much? Let's say F. We don't know whether it is moving together or not, right? So what we can assume that the friction is first static in nature. This important point. We do not know whether when you apply the 40 Newton force, both would have same or different acceleration. So first point, what we will assume, they are moving with same acceleration. And when they are moving with same acceleration, the friction between them would be of a static nature. And static friction can have any value from 0 to F max. We don't know that value. So we'll assume that friction is generally F. Okay. And 2 kilogram, when you draw the free body diagram, forward friction F. Okay. Now this is 40 Newton and friction maximum available how much? 10 Newton. Okay. Let's see their acceleration. 40 minus F equals to 10A. We are assuming that both are moving with the same acceleration. And F equals to how much? 2A. So from there we'll get that 40 equals to 12A and acceleration is 40 over 12. Putting this acceleration back in the friction, so you'll get that the friction is how much? 2 into 40 by 12. So it is 40 by 6, that is 20 by 3. Approximately how much? 6.67. That is the friction. Okay. This is the friction value that is required to take the blocks together. And how much available we have in stock? The friction is 10 Newton. So it means that the friction is sufficient to provide the required value. Required value is coming out to be 6.6 Newton. It means that this case is true and both the blocks would move with same acceleration. Their acceleration would be how much? 40 by 12. Got it? Acceleration would be 40 by 12 and friction between them would be 6.6 Newton, and this friction is of what nature? Static nature. Clear? With first part it is clear or not? Okay. Let's see the second case. In the second case, what we are doing now, force become here how much? 60 Newton. So what would change? So this force 60. So we'll do this one 60. Let's do some amendment here. It would become 60 minus F. So that one also be 60. So acceleration would be how much? 60 by 12, that is 5 meter per second square. Got it? So second case acceleration is how much? 5 meter per second square. Good. Let's calculate the friction value then. If acceleration is 5 meter, then how much friction is required? How much friction is there in between? So friction would become how much? 2 into acceleration, that is 10 Newton. Okay, that is our required friction to take the blocks together. That is how we will solve these problems. First, we will assume that both the blocks are moving together. Okay, then we will calculate the value of acceleration and friction. And from friction, we'll compare it with the maximum available friction. So here required friction is how much? 10 Newton. Required to take the blocks together. This is our requirement. For what? To take the blocks together. Because that's what friction would do. It would try to prevent the sliding motion between the two particles. So it would try its best. Okay. So here requirement is 10 Newton and availability is also how much? 10 Newton. So tell me, the condition would be satisfied or not? Yes, the condition would be satisfied, and both the blocks still would move with same acceleration, that is 5 meter per second square, and friction acting between them would be how much? 10 Newton. And this is also which friction? Static part of the friction. The blocks are moving with the same acceleration. Okay. Let's see the third part of this problem now. So in third part, first of all, we'll remove some of the data here that we have done. Third part. Third part is saying that we are applying here 80 Newton. So this would also be 80. So this would also be 80. So some calculation here will be different. So forward 80 Newton, backward friction, forward friction. So 80 minus friction equals to 10A, friction equals to 2 into A. These are the equations. Adding them together again, so we'll get 80 equals to 12A. So 80 by 12, 420 by 3. 20 by 3 something, let's keep it for the moment, 20 by 3. So if you talk about friction, friction would become how much? 2A, that is 20 by 3 into 2, 40 over 3 Newton. So 40 over 3 Newton is obviously more than what? 10 Newton. Okay. So this is our required friction, 40 by 3 Newton. And this requirement is more than availability. Maximum friction how much? 10 Newton. Clear? Maximum friction that the blocks can provide is 10 Newton. And requirement here is 40 by 3 Newton. So simple. They are not going to move together. There would be a relative slipping between them. So now what we will do? So when this case arises, when the requirement is more than the availability, then we will talk about slipping between the blocks. Now, when the blocks are slipping, they would have what? Different accelerations. Okay. And which kind of friction would act between them? The friction would be kinetic friction. Got it? Kinetic friction would act between the blocks because there is a relative motion. Okay. So let's see this, solve this third part again now. These are the steps that you have to follow. Okay, so friction, now we know how much, because we already know that friction is, let me remove these parts. We already know friction how much, tell me. Friction is kinetic in nature, and kinetic friction, that is given by F max mu into normal, that was 10 Newton. So friction backward here also 10 Newton. So acceleration of this block would be how much? Acceleration of this block would be 80 minus 10, 77 meter per second square. This is the acceleration of 10. Similarly, acceleration of 2 would be how much? Force by mass, that is 5 meter per second square. Both move with different acceleration, and friction between them would be kinetic friction, that is 10 Newton kinetic. Got it? So this is the detailed analysis of block over block problem.